This video is, again, we're doing a lot of optimization problems here. And so it's all the same. All right, now we have a rectangular page that is to contain 30 square inches of print. And the margins on each side are 1 inch. Find the dimensions of the page so that the least amount of paper is used. Keep in mind, again, anytime you can, you're going to be wanting to draw a picture. And so if we draw a picture, then we have a piece of paper. I don't know what the dimensions are, but it is rectangular. The words on the page are rectangular. And so if we write a bunch of stuff down, then we have consistent, not according to my drawing, but we have a consistent 1 inch margin all around. And now find the dimensions of the page so that at least, okay, so now we don't know what or how much print is used on each. So let's call this X, let's call this Y. So if we look then, the area of this whole piece of paper then is going to be X plus 2 times Y plus 2. Okay. Now for our secondary equation, we're going to be doing something a little bit different here. And so let's see, grab a different color. Now this is our primary. Let's go ahead and mark that as our primary. Primary. This is the one that we're going to be taking the derivative of and maximizing, minimizing, that sort of thing. Okay, now for our secondary, we do know something about the area of the print. The area of the print is equal to 30 square inches. All right, so now we also know that the area of the print is equal to x, y. And so we could set xy is equal to 30, which if you do that, then xy equals 30 implies that you have x is equal to 30 over y. Well, now you've got something. You can take that and shove that right back in for x. So we come back to our original formula here, and we have our full area is equal to 30 over y plus 2 times y plus 2. So just go ahead and expand this out. And you don't have to expand this out. I always find it a little bit easier. And so I'm just, because it's a nice binomial here. So y times 30 over y is just going to be 30. 30 over y times 2 is going to be plus 60 over y plus 2y plus 4. So now I've got a is equal to 2y plus 60 over y plus 34. All right, so not bad. So now we can go ahead and just take our derivative. The derivative of a with respect to y is equal to 2 plus, now this is going to be, if you bring the -1 down and that becomes a -2, so this is -60 over y squared, and that's it. And so now set that equal to 0, 2 plus -60 over y squared. And now you have -2 is equal to -60 over y squared. Multiply both, multiply by y squared divided by -2, so you have y squared is equal to 30. Y is equal to the square root of 30. And now I'm not seeing anything. It's 6 and 5, so there's nothing that we can pull out and make it nicer. And so now we have y is equal to 30. And we have, because of x is equal to 30 over y. And so x is equal to 30 over y, which is 30 divided by root 30, which is the square root of 30. And so x and y are the same. But now it says, if we go back up to the question, that's not what it was asking. It was asking, what are the dimensions of the page? so that the least amount of paper is used. And so now we have to go back up and we say just add 2 to x and y, and there's the dimensions of the page. So page dimensions y plus 2 is square root of 30 plus 2. So when we defined it, this is really our height. And then our width is equal to, square root of 30 plus 2. And so we're just having a square piece of paper.